In this video, I'm going to be teaching you on the purification table as far as enzyme purification is concerned. This table is very important because it gives the overall summary of whatsoever happens in a purification process. And as we have it in this sheet, you notice that we have different type of steps of purifications, and this is crude enzymes, ammonium sulfate fractionation, ion exchange chromatography, then affinity gel filtration, and affinity chromatography. And the volume of the enzymes has been given to us according to the table. And you will notice that all these things has a definite value, but in most cases, in fact, every time, only the volume of the enzymes is compulsory to be given. In that means it means that you can actually calculate for all that stuff that is inside this table, from activity of the enzymes to the proteins, then to the specific activity and the yield, which is in percentage, and the purification factor. So in this video, I'm going to be giving you a shortcut formula that you need for you to get any of these five concepts. Now, you know, this table, this sheet is showing you 1, 2, 3, 4, 5, 6. So I'm going to be talking about 1, 2, 3, 4, 5, how you can calculate them: activity, protein, specific activity, yield, and purification factor. But volume must be given. Now, let's start. So if you see this sheet, you will see that in this sheet, I target calculation on purification table. So anytime you want to calculate for the volume of an enzyme, as you can see, I said that it must be given. So there's no how you can calculate for it. You have to have it in your table. But how can you calculate for the enzyme activity? Enzyme activity. Where is the enzyme activity? The enzyme activity, according to this table, is this: 3,000. Now, the formula I put here is PSA, where P represents what I call the proteins and the S represents specific activity. It means that enzyme activity equals to the product of protein and specific activity. Product of the protein and specific activity. So let's take this table now. I said enzyme activity equals to PSA, which means protein times specific activity. So let's look for how can we calculate the enzyme activity of crude enzyme. The enzyme activity of the crude enzyme is 3,000. So how can we get it? Is when you multiply the protein, which is 15,000, multiplied by 0.2, which is specific activity. So when you do that, you can pause this video and take your calculator. 15,000 times 0.2 is as if you are saying 15,000 times 10 divided by 2. 15,000 times 2 divided by 10. If you do that, it's going to be 3,000. Then that's how I actually get this. So that means anytime you are looking for enzyme activity, you are going to use protein multiplied by specific activity. But in case you are still doubting, let's take another purification steps. Let's take the one for ammonium sulfate fractionation. How can you calculate the activity of ammonium sulfate fractionation? As I've told you, enzyme activity is protein times specific activity. So just go to the protein of ammonium sulfate fractionation, which is 4,000, and multiply it with your specific activity. So if you multiply 4,000 times 0.6, you are definitely going to get 2,400. You get it now? So I think we are done with that. So let's move to the next one, which is what? Mass of protein. How can you calculate the protein in a purification table? The formula here, as you can see, is A all over SA. You know, I've already used SA here before. SA means specific activity, while A means activity. So there's a difference between activity of an enzyme and specific activity, in that one is more specific, while the other one is not specific. So A here means activity, while the SA means specific activity. So according to this formula, it means that whenever you have to look for mass of protein, just divide your activity by your specific activity. So let's take, for example, if you have to look for the mass of protein of ion exchange chromatography, which is 500, we want to get, how do they get this 500? According to this formula, we said activity over specific activity. So you are going to look for the activity of that particular steps. The activity of that particular step is 1,440, and the specific activity is 2.0. So by the time you divide 1,440 by 2.0, you are going to get your 500. 1440 by 2.0. But one thing that is here is that this thing is wrong. This 2.0 is wrong because the actual value is supposed to be 2.88. When we get there, I'm going to explain how you can calculate your specific activity. Now, if you have to calculate specific activity, though I'm not there yet, but because of this error, as you can see, I've already changed it. It should be 2.88, not 2.0. So when you divide your activity, which is A, by your SA, which is specific activity, so our activity here is 1,440, and our specific activity is 2.88. So when you divide 1440 by 2.88, you must definitely get 500. That's how we get it. So please take note of this formula. So mass of protein equals to activity all over specific activity. Now, what of specific activity? That's the fourth one. If you want to calculate specific activity, the formula is activity divided by protein. So just divide your activity by protein. Mass of protein, you divide activity by specific activity. Specific activity now will now be, in this formula, mass of protein equals to activity over specific activity. So if you now want to calculate for specific activity, that means specific activity will take the place of mass of protein, while mass of protein will now come to the denominator. When you do that, that means specific activity is now equals to what? Activity all over protein. So let's check. How can we calculate specific activity for affinity chromatography? Under the specific activity, you will see that the answer is 40. This is wrong. The answer is supposed to be 10. That's why I've corrected it. Because the formula says specific activity, can you pause? Specific activity